Today we are going to study linear inequations. Now, what is a linear inequation? We very well know what a linear equation is. Example, 3x plus 2 is equal to 5. Here, degree of x or the highest power of x is 1, so it is called linear. And we have the sign of equality, so it is called equation. So this is a linear equation. Now, we change the sign of equality to the sign of inequality. We get a linear inequation. Which are the signs of inequalities? Greater than, less than, greater than equal to, less than equal to, not equal to. Why do we use linear inequations? Linear equations are used to get the exact value of x, whereas linear inequations will give us the range of x, that is, it tells us x lies between which two values, or x is greater than some number or x is less than some number. Now, next question what comes to our mind is, how do we solve a linear inequation? A linear inequation can be solved in the same way like a linear equation. The only difference is we maintain the sign of inequality throughout the sum. Now, we are going to learn some properties on inequations. If A greater than B and we wish to add the same number, say C, on both the sides, we get A plus C greater than B plus C. Same way, we subtract the same number C from both the sides. We get A minus C greater than B minus C. Now we multiply both the sides by the same number C. Here we have two cases. Either C is positive or C is negative. Take an example, 6 greater than 4. Take C as 2. We get 12 and 8. Obviously, 12 is greater than 8. So the sign of inequality remains the same when we multiply both the sides by a positive number. Now let's multiply by a negative number. Same example, take C as minus 2. We multiply by minus 2, we get minus 12, minus 8. Now which is greater, minus 12 or minus 8? Obviously minus 8. So we have got minus 12 less than minus 8. That is, the sign of inequality is reversed when we multiply by a negative number. Now let's divide both the sides by the same number C. Same example, 6 greater than 4. Take C as 2. We divide, we get 3 and 2. Obviously 3 greater than 2. So the sign of inequality remains the same when we divide by a positive number. Now let's divide by a negative number. Take C as minus 2. We get minus 3 and minus 2. Here we get minus 3 less than minus 2. That is, the sign of inequality is reversed when we divide by a negative number. Now this is going to be the most important property for this topic. That is, whenever we divide or multiply by a negative number, the sign of inequality is reversed and it remains the same in all other cases. One more example, we have minus 4x greater than minus 8. Now what will x be? Will x be greater than 2 or less than 2? How can we find x? We have to divide both the sides by minus 4. Now we are dividing by a negative number, so the sign should reverse. That's why we will get x less than 2. Prerequisites for this topic. What are whole numbers, natural numbers, integers, real numbers? Natural numbers. These are numbers starting from 1, 2, 3 and so on. They are denoted by n. Whole numbers, they start from 0 and go on to infinity. They are denoted by capital W. Integers, these are negative numbers, 0 and positive numbers. They are denoted by capital I or capital Z. Now what are real numbers? Real numbers are the set of all possible numbers, that is decimals, fractions, integers and so on. In this topic, we need to solve the linear inequation. On solving, we get a solution set. We need to graph that on the number line. Let's see how we are going to draw the graphs of inequations. Now we will have different cases over here, that is x belongs to natural numbers, whole numbers, integers or real numbers. We've already seen what these numbers are. Now first example, x greater than -1 less than 3, x belongs to n. Here since x is a natural number, what values can x take? X can take 1 or 2. So we draw the number line and on that we mark dots at 1 and 2. Our number line is ready. Now the second example, x greater than -4, x belongs to integers. Here we have x belongs to integers, that is x can be -3, -2, -1, 0, 1, 2, 3 and so on. Here x is greater than -4, so -4 is not included. Now we mark dots at these places and since it's going up to infinity, we mark 2 extra dots on the number line as shown here. Third example, x less than 4, x belongs to whole numbers. Now we have x less than 4 and whole numbers start from 0. So we have 0, 1, 2, 3. 4 not possible because we are given x less than 4. Now we mark dots at 0, 1, 2, 3 and the number line is done. Next example, x greater than -4 less than equal to 2, x belongs to real numbers. Now as we've seen earlier, what are real numbers? They are the set of all possible numbers including decimals, fractions, integers and so on. Now here, can we say the numbers of the set? In this case, it's not possible to say the numbers of the set because it will contain decimals also. So in such a case, we draw the number line. Now -4 is not included in the set. So at -4, we draw a curve. And 2 is included in the set. So we draw a straight line at 2. Now join these two by a straight line and shade the area between these two. Then the number line for real numbers is ready. Now in this we have an alternate way of doing. Since -4 is excluded, we draw a straight line and a circle on top of it. We do not shade that circle. Now since 2 is included, we draw a straight line and a circle and shade that circle. Join these two by a straight line and shade the area between them. Now one more method is at -4 on the number line itself, we draw a circle. Do not shade it because -4 is excluded. At 2, we again draw a circle but shade it because 2 is included. Darken the line between these two. So this is the third method how you can draw a number line for real numbers. Let's take one more example. X greater than equal to 2, x belongs to R. Now here we have greater than equal to 2. It means starting from 2 up to infinity on the right side. So at 2, we draw a straight line and we draw a line parallel to the number line which goes up to infinity. And we shade the area between them. Now we'll be solving some problems on linear inequations. First one, find the solution set of the following inequation and represent the solution set on the number line. 3x upon 2 minus 1 less than x plus 1 upon 4, x belongs to I. Now here we have 4 in the denominator on the right side. So we take the LCM throughout as 4. Now we get 6x minus, now we have 1 in the second term, we can write that as 4 upon 4. So on the left side we get 6x minus 4 upon 4, right side as it is. Now since we have 4 on both the sides, we cancel them. So we are left with 6x minus 4 less than x plus 1. Now we transfer x from the right to the left and we transfer minus 4 to the right. We get 6x minus x, that is 5x, and on the right we get 1 plus 4, 5. Now divide both the sides by 5, we get x less than 1. And x is an integer. So what values can x take? X would be 0, minus 1, minus 2 and so on up to infinity on the negative side. Now here it is a compulsion. We write down the solution set. So the solution set will be written as, now we need to draw the number line. So we draw the number line and we put dots on 0, minus 1, minus 2 and so on, and we will put 2 extra dots to show it is going up to infinity on the negative side. Now let's start with the second problem. Solve the following inequation and graph the solution set on the number line. Minus 3 less than 3 minus 2x less than 9, x belongs to R. Here we have two signs of inequalities, so we will separate them and consider them as two different inequations. Let's take the first inequation, minus 3 less than 3 minus 2x. Now we want to solve this, that is to make x the subject of the inequation. So we transfer minus 2x to the left and minus 3 to the right. We get 2x less than 3 plus 3, that's 6. Now divide by 2, we get x less than 3. Now take the second inequation, 3 minus 2x less than 9. Here we have minus 2x. We transfer 3 to the other side. We get 9 minus 3, that's 6. But we have minus 2x less than 6. Now you remember, when we divide by a negative number, what happens to the sign? The sign should reverse. It might be possible in the exam we might forget doing this. So we will try and keep the coefficient of x positive as far as possible. So we do not do this. We instead transfer minus 2x to the right side and make it 2x and bring 9 to the left. So we get 3 minus 9 less than 2x. That is minus 6 less than 2x. Divide by 2, minus 3 less than x. Now we rearrange them as minus 3 less than x less than 3. Your x belongs to real numbers. Now when we have real numbers, we cannot say the elements of the set. We need to write it in the set builder form. Do you remember the set builder form? It's the x such that form. So solution set will be x such that minus 3 less than x, less than 3, x belongs to R. Now we draw the number line. Minus 3 is excluded from the set. We draw a curve. Similarly, 3 is excluded. We draw a curve at 3. Now join these two curves by a straight line and shade the area between them. Now please note, whenever we draw a number line, we should have at least 2 extra numbers before and 2 extra numbers after the required solution set. Now to the next problem. Solve minus 3 less than equal to 2x minus 5 less than 15 minus 3x, x belongs to n, and graph the solution set on the number line. Here again we have two signs of inequalities, so we'll separate them and solve as two inequations. The first inequation will be minus 3 less than equal to 2x minus 5. We transfer minus 5 to the left. We get minus 3 plus 5, that's 2, less than equal to 2x. Now divide by 2, we get 1 less than equal to x. Now take the second inequation, 2x minus 5 less than 15 minus 3x. We take minus 3x to the left. We get 2x plus 3x, 5x, and take minus 5 to the right, we get 15 plus 5, 20. Now divide both the sides by 5, we get x less than 4. Here x is a natural number, so we have x greater than equal to 1 but less than 4. So x can take values as 1, 2, 3. We write down the solution set as, now we draw the number line and mark dots on 1, 2, 3. Here's the next problem. Solve 2x minus 3 less than x plus 2 less than equal to 3x plus 5, x belongs to R, and graph the solution set on the number line. Here again we have two signs of inequalities, so we separate them as 2x minus 3 less than x plus 2. Transfer x to the left and minus 3 to the right. We get x less than 5. Now the second inequation, x plus 2 less than equal to 3x plus 5. Now here we have x and 3x. If we take 3x to the left, we will get minus 2x. We want to avoid that, so we take x to the right and take 5 to the left. We get 2 minus 5, that's minus 3, and 3x minus x, that's 2x. Divide by 2. Minus 3 by 2 less than equal to x. Now we join the two inequations to get minus 3 by 2 less than equal to x less than 5. X belongs to R. Now since it's real numbers, solution set will be in set builder form. We have it as this. Now we draw the number line. Minus 3 by 2 is included in the set. Minus 3 by 2 means minus 1.5. So at minus 1.5, we draw a straight line and 5 is excluded from the set. So we draw a curve at 5. We join these two by a straight line and shade the area between them.